Let's solve this system of three linear equations with three unknowns using the elimination method. To start with, we notice that we can right away add equation 2 to equation 3 and eliminate the y variable. So let's add those two together, and what that'll give me is 4x plus 4z is equal to 8. And we'll call this our new equation 4. Now, since we eliminated the y using 2 and 3, we need to eliminate the y also using 1 and one other equation. So let's use equation 2 and multiply it by 4 and add it to equation 1. So when I multiply it by 4, I'm going to go 12x minus 4y plus 8z is equal to 32. And our equation 1 was 2x plus 4y plus 3z is equal to 5. And if I add these two equations together, what I'm going to get is 14x plus 11z is equal to 37. Now, we'll call this one equation 5. So we have equation 4 now and equation 5. Two linear equations with only two unknowns. Let me rewrite them so that we can see them a little easier. If I add over here 4x plus 4z is equal to 8, this is our equation 4. We have this new system with equation 5 and equation 4. Now that we have equation 4 and equation 5 up here, we need to solve this system of two linear equations with two unknowns using the elimination method also. Let's eliminate our x's by multiplying equation 5 by a 4 and equation 4 by a negative 14. This new system will then be 56x plus 44z is equal to 148, and our other equation will be negative 56x minus 56z is equal to negative 112. And if I add these two equations together, what I'm going to get is negative 12z is equal to 36. Now if I divide both sides by negative 12, I get z is equal to negative 3. So this is the z coordinate of our solution. Now to find the next coordinate, what I'm going to do is I'm going to plug this negative 3 in for z in equation 4. So that'll give me 4x plus 4 times my z, which is negative 3, is equal to 8. And if I simplify this or solve for x, I will have 4x minus 12 is equal to 8. And I'll add 12 to both sides, which will give me 4x is equal to 20. And divide both sides by 4 and get x is equal to 5. So there's the x coordinate of my solution. To get my y coordinate of my solution now, I will plug x and z into equation 3 and solve for y. So this time I'll have 5 plus y plus 2 times my z, or negative 3, is equal to 0. And if I solve this equation for y, I'm going to have 5 plus y minus 6 is equal to 0, or y minus 1 is equal to 0, or y is equal to 1. So now that I have all three parts of my solution, I'll write them as an ordered triple now, which is my x coordinate of 5, my y coordinate of 1, and my z coordinate of negative 3. So my solution here is this ordered triple, 5, 1, negative 3.